Unlike straight lines, nonlinear functions do not have a constant slope. We can hopefully see this pretty easily from looking at the two graphs we have pictured here. Neither curve is moving in the same direction at the same rate for the entirety of the portion of the graph that we're looking at. So once we start talking about nonlinear functions, we generalize the concept of slope into what we refer to as rate of change. It's still a very similar idea to slope, but with the slope changing at different points along the curve. Again, we're just generalizing that idea and referring to it as a rate of change, which can be different at different points along the curve. To calculate the average rate of change of a function, we take two input values, the average rate of change between two input values is the total change of the function values divided by the change in the input values. That is a very wordy way to say that to calculate the average rate of change of a function, we're going to take the difference of two y-coordinates divided by the difference of its two corresponding x-coordinates, of their two corresponding x-coordinates. But those 2 points, x1, y1, and x2, y2, are going to be specific points along our curve. So if we chose this first point to be x1, y1, and x2, y2, and plug those values into this equation that we just set up, what we're doing is calculating the slope of a straight line passing through those 2 points. So what we think of is a line passing through those 2 points on a curve, and we refer to this line that we just constructed as the secant line. We could look at doing the same thing with our second graph here. If we pick 2 points, x1, y1, and x2, y2, we can draw a straight line passing through those 2 points, which we again refer to as the secant line, and we can calculate the average rate of change of the function over this interval from x1 to x2 by finding the slope of that straight line, using the slope formula exactly as we did just a minute ago. In example 2, then, we want to find the average rate of change of this function on the interval from -2 to 0. This is giving us our x1 and our x2 values. So we want to look at x equals -2 and find that corresponding function value, which in this case would be +4. And then for our second point, we'll look at x equals 0, and here our y-coordinate is 0, meaning to find the average rate of change of our function, we need to find the slope of the line passing through these 2 points. To do that, we'll take the difference of our y-coordinates divided by the difference of the x-coordinates, making sure we use the same x-coordinate, or use the x-coordinate paired under its corresponding y-coordinate. So this will be -2 minus 0, giving us 4 over -2, or a slope of -2. This answer makes sense because the slope that we came up with is less than 0, and our secant line is decreasing, meaning that line should have a negative slope. For example 3, we want to look back at that same graph in example 2, but now find the average rate of change from x equals -2 to x equals 2, meaning we have a different pair of values for x1 and x2. We have the same starting point, -2, 4, but now we'll introduce the endpoint of 2, 4, and draw a new secant line passing through these 2 points. We'll evaluate the slope formula again, taking the difference of our y coordinates over the difference of our x coordinates to get 0 over -4, or just 0. Again, this result makes sense because if we drew our picture well enough, we should be able to see that that secant line passing through those 2 points is a horizontal line. Horizontal lines have a slope of 0. In example 4, we have a new curve, and now we want to find the average rate of change for this between x equals 0 and x equals 4. Again, that's our x1 and our x2 value. So we'll start off with one point at 0, 0, and another point at x equals 4, y equals 2. Connecting those 2 points gives us our secant line, and to find the average rate of change, we just want to find the slope of that secant line. To do that, we'll take the difference of our y coordinates divided by the difference of our x coordinates, and we'll get 2/4, or 1/2. Here, the slope of that line is positive. The secant line that we drew is an increasing line, so that checks out with our expectations from looking at that secant line.